Hello everyone. Now we have to discuss another important concept of calculus, that is integration, right? We have already studied differentiation. So today we are studying integration. And when we study integration, we will get to know how these differentiation and integration concepts are related to each other and how and where to use it in physics. Right? So we have studied differentiation. We know that we use differentiation whenever we check the variation, instantaneous variation of one quantity with respect to the other. That means we take a very small amount of that quantity for differentiation. But when we want to analyze the problem, then we use differentiation, and when we use to see the whole view, overall view, then we use integration. As the word itself indicates, integration is summing up and differentiation is breaking down. So before we proceed, I just want to tell you some basic differences between the concept of integration and the differentiation. So differentiation we have already studied, and integration we have to study. Right? So differentiation means if we have a long rod of length x, we'll take an example for a particular length later on. Then if we want to take a very small length such that this very small length cannot be subdivided further, then this small length can be taken as dx, 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 right? So this is breaking down. And in case we are using integration, we already have these small parts, right? And we add these small parts to find the total length. Now when we are using this word sigma, we have used this sigma symbol in class 9th also. But here for integration, we are not using this sigma letter. We will be using this symbol, integration. This is the symbol of integration. Now why this integration symbol is used? Why don't we use sigma? Because sigma is used for adding discrete values. Discrete values means, suppose I want to add some masses, m1 is 1 kg, m2 is 2 kg, m3 is 4 kg. Then what will be sigma m? Sigma m will be the sum of these values. And this will be 1 plus 2 plus 4. So this makes it 7. But integration is used when we are adding continuous values. When we add continuous values. What does that mean? That means if we add dx, then next dx, then next dx, all the dx's taken in continuity and added together, then only these will give us the complete length x. So first thing is, differentiation is breaking down, and integration is summing up. This is summing up. And this we use to apply for adding the discrete values, and integration we use for continuous values. So this is the symbol of integration. Right? So, when we are integrating something, the quantity which we are integrating, that quantity, the smallest part of that quantity is used along with this integration symbol, then this whole quantity is called as the operation of integration. Right? Now let's take the basic formula for discussing integration. Right? And how this integration is related to differentiation, let's check that also here. We know that if we have a function y which is function of x, then we know that how do we find this differentiation? This differentiation is rate of change of y with respect to x, and this can also be written as f dash x, where f dash x is differentiation of fx. Fx is what? This is y. Right? So that means if I want to find dy, from here dy can be written as f dash x. Or I can say that f dash x dx can be written as dy. Right? Or when we integrate both the sides, whenever we apply the differentiation operation, it is always applied on both the sides together. And similarly, integration is also applied on both the sides together. Right? Now look at this. If we add dx, 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 what will it give? If these are adding continuity, it will give x. Similarly, if dy, dy, dy are added together, we will get y. So y is what? Integration of f dash x dx. Right? This will be more clear if we take the basic formula and understand the basic operation, how we apply it. Right? So now we take this. Now, let's take the basic formula. If y is equal to x to the power n, right? So, if I want to integrate this x to the power n dx integration, the formula of, we know that this part and this part, that means this shows the operation of integration. So if we are finding the formula for the integration of x to the power n, this is the basic, the simplest formula. So we can write that this is integration of x to the power n dx is given by x to the power n plus 1 upon n plus 1. This is the formula for integration. Just recall, for differentiation of x to the power n, what was it? D by dx, right? This was n x to the power n minus 1. Remember? So just check, integration and differentiation are just opposite. Here we are adding 1 and we are dividing by this quantity after adding. There we were subtracting 1 and we were multiplying by this quantity, this power, before subtraction. So this is the basic formula. Let's take an example. For example, if we have x to the power 5 and if we have to find out the integration of x to the power 5. So for n We have 5 over here. So what will be its integration? X to the power 5 plus 1 upon 5 plus 1. This is equal to x to the power 6 upon 6. Right? And this kind of integration where we are not having any upper limit or lower limit, this kind of integration is called as definite integral, right? I'll tell you how to apply that later on, but first let me discuss some basic rules to be taken care of while using this concept of integration. So, when we are adding or subtracting two terms, then the integration is applicable separately to both the terms. So first rule is similar to differentiation only, that if two or more quantities are added or subtracted, then operation of integration is applicable to every term separately. Second point, what does that mean? Let me explain that first. Suppose we have this x to the power 5 plus x to the power 4. Then if I want to integrate this complete term, right, then what will happen? This integration is applicable separately to this and to this, right? Similarly, if we have constant, then integration of constant is not 0. We had differentiation of constant 0, but if constant is there, the integration of constant is not 0, right? So this is contrary to the rule which we used in differentiation. Then third point is, if a constant is in product form, with the quantity which is being integrated, then it is kept outside the integral sign. Right? So let's take this case also. If we have to integrate 5x4, right? So that means 5 will be taken outside this and then it will be integrated. So we will apply all these rules together in the next example, right? So we are studying this integration for physics. So I am just trying to simplify the things in a way that you are able to understand the physics concepts. Otherwise, this is a very technical concept and discussed in very detail in mathematics. So let's take an example over here. Suppose we have to integrate. Suppose we have to integrate x to the power 4x to the power 3 plus 2x square plus 1, right? So what will be its integration? Its integration will be, if we integrate it, integration of this will be applicable to every term separately right, and then this can be kept outside the integral sign because this is a constant. Similarly here this can be kept outside this integral sign, and this, though by logic also we know that 1 can be taken here and dx integration will be x, but I will tell you how this comes out to be x. I can say that 1 can be written as x to the power 0 because anything to the power 0 is 1. So this gives us 4 x to the power 3 plus 1 upon 3 plus 1 plus 2 as it is, x to the power 2 plus 1 upon 2 plus 1 plus x to the power 0 plus 1 upon 0 plus 1. So we get this result here, 4 upon 4 x to the power 4 plus 2 x to the power 3 upon 3, right, plus x. Now look at this term, dx integration is x, and how it is x? I have explained it, because you can write 1 as an x to the power 0. So that way it will be x on integrating using the formula. How I have applied all this? Because we know that x to the power n dx integration is equal to x to the power n plus 1 upon n plus 1. This formula we have used here. Now, we have already discussed how to apply differentiation in physics. Now, let's take an example to understand how this integration is applied in physics, right? So, let me rub this board. Now let's recall. We know that acceleration is dv by rate of change of velocity. So this is dv by dt, right? So we can write this like this, dv is equal to a dt, right? And if I am given an expression of acceleration, it is also a function of time. If I am given an expression of acceleration, then I can integrate both the sides. This dv will be v on left side, and on integrating the expression for acceleration, I will get the expression for velocity. We will take an example to understand this, but first try and recall this. This is first, this is second. Let's take. Now, velocity is what? Rate of change of displacement. So you can say that this is dx by dt, right? So if I want to find the expression of displacement from velocity, I can cross multiply it and write dx on one side and v dt on the other side. If I integrate both the sides, the integration of dx will be x and This means if we integrate the expression for velocity, we will get displacement. Let's take an example to understand this. Now the example I am taking here is, for example, if acceleration is given by 2x square plus 3x plus, acceleration is a function of time, right? So I don't have to use t here. So this is suppose 2t square plus 3t plus 5. So acceleration is function of time. That's why this expression is given in terms of as variation of acceleration with time. So what we have to do is we have to find the velocity. So again I can write this like this, dy by dt is equal to 2t square plus 3t plus 5. So this way what will I get? dv is equal to 2t square. This I am doing by cross multiplication. So I have taken this dt here by cross multiplication. So on integrating both the sides, that means I am integrating both the sides. So left side, what will remain? Integration of dv is v, and this integration is applicable to every term separately. So I am writing this 2t square dt plus integration of 3t dt plus integration of 5 dt. So this will give me 2 outside the integration sign plus 3 outside the integration sign plus 5 outside the integration sign. So this gives me 2 t to the power 2 plus 1 by 2 plus 1 plus 3 into t to the power, here power is 1, right? So 1 plus 1 upon 1 plus 1 plus 5. What is the integration of dt? Simply it is t, right? So what is the expression for velocity here? This will be 2 upon 3 t cube plus 3 upon 2 t square, right? Plus 5t, right? So if in the question it is asked that you have to find the velocity, find velocity at t is equal to 1 second. What will I do? I will simply put the value for time as 1. Right? And this will give me the value of the velocity. So this is 2 upon 3 plus 3 upon 2 plus 5. So this will give me 6 and 2 is 4 plus 3 is 9 plus 30. So whatever it is, 34 plus 9 is 43 upon 6 meter per second. Right? And if we talk about the expression for velocity, we get this expression of velocity by integrating acceleration. Right? So if we have this expression given, and first part is find velocity. So we have calculated the expression for velocity in the first part, right? And what is the second part? The second part says that we have to find the displacement. So we are finding displacement now. So for this we know that v is, this is your expression 1, let's say. So from expression 1, v can be written as dx by dt. And this is what? 2 by 3 t cube plus 3 by 2 t square plus 5 t. Right? So dx can be kept on one side and 2 by 3 t cube plus 3 by 2 t square plus 5t can be kept on the other side, and I can cross multiply this like this. Now after this I can integrate both the sides to find the expression of velocity. So this is the symbol of integration, right? So from here, I hope you understood this concept. Now I need to rub the board for next part, right? So let's check this part. Now from here, I'm writing here. So integration of dx is x. 2 by 3 can be kept outside the integration sign. So inside this will be t cube dt. Right? And 3 by 2 can also be kept outside the integration sign. So this will be t square dt. Plus 5 can also be taken outside the integral sign, and this will be t dt. Right? So from here, this will be t to the power 3 plus 1 upon 3 plus 1 plus 3 upon 2. T to the power 2 plus 1 upon 2 plus 1. This is by formula. X to the power n, integration of x to the power n is x to the power n plus 1 upon n plus 1. So here we are integrating with respect to time. So that's why we are comparing that x to the power n formula by t to the power n formula. So 5 t to the power 1 plus 1 upon 1 plus 1. So this gives us 2 upon 3, right? Into t to the power 4 upon 4 plus 3 by 2 t to the power 3 upon 3 plus 5 t to the power 2 upon 2. So whatever can be cancelled, we can cancel it. So this will be cancelled and this will be cancelled. So what will be the expression? Expression for displacement will be t4 by 6 plus t cube by 2 plus 5t square by 2, right? So this gives us the expression for the displacement. Now if I want to find the value of displacement at time t is equal to 1 second, at t is equal to 1 second, if I want to find x, so this will be 1 upon 6 plus 1 upon 2 plus 5, 1 upon 2. So this gives us 1 by 6 plus 1 by 2 plus 5 upon 2. So we can calculate the x from here. So this will be 6, this is 1 plus 3 plus 15, that is 19 by 6 meters. Right? So this is how we calculate velocity and displacement if acceleration is given. So one very important point to note over here is, right, integration is used when we have to find velocity from acceleration and displacement from velocity. So integration is used to find, number 1, velocity from acceleration, right, and number 2, displacement from velocity, right. And second important point is differentiation is used to find first velocity from displacement, right, and acceleration from velocity. These are very important points, so we need to keep this in our mind. Now one more point about integration is left. Integration is summation, or you can say continuous summation, or summation of the continuous terms. So let's take a case. If we have to sum up something from particular limit to particular limit. Suppose we have a length 10 meters, right? And I want to integrate. This is again dx, 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 dx will make it the complete length. So that means its limit is 0 to 10 meters, right? So that means if I am integrating this dx from 0 to 10 value, right, then we will get how much? Integration of dx is x. And when these limits are given, then after integrating, we put the value of upper limit and then put the value of lower limit. Such kind of integration where limits are applied is called definite integral. When limits are not applied, then we say that it is an indefinite integral. So here in this case, what is the integration? First we integrate and then we apply the limits. That means now we are applying value of x as 10 because the values of limits are in the terms of the quantity with respect to which it is integrated. So this will be 10 minus 0 is equal to 10 meters. Now if I change the limits, right, if I say that we have to integrate dx, we have to sum up dx such that we have to integrate it from 2 meters to suppose 8 meters, right? So what will we do? Integration of dx as before, integration is x. Now what will be our limits? 2 to 8. So this will be, upper limit is 8, lower limit is 2. So this will give us 6 meters. Now you will say, what special have we done here? We know that 8 minus 2 is 6. But this was the simplest example taken by me to explain you how these limits are applied to find the values within those particular limits. So the integral where limits are applied is called definite integral. And for that, we will first integrate. Here, we first integrate and then apply limit of the quantity with respect to which we are integrating. And how do we apply the limit? Upper limit minus lower limit, right? And these limits, this is very important point here if you want to write down. So limits are for the quantity with respect to which we are integrating. Right? So such an integral is called definite integral, and integral without limits is called indefinite integral, right? So you have to remember these points because we will be using all these concepts while deriving the equations of motion by calculus method. Hope you understood well. That's all for now. Thank you.